Good day, everyone. A warm welcome to this program. I think on behalf of the Singapore Battery Consortium, we are very pleased to bring you this session. The Singapore Battery Consortium that started about 1.5 years ago aims to be a premier platform that gets together both companies, researchers, scientists to look at the area of battery technologies. As you know, batteries is becoming an increasingly important area that's very pervasive in our life. It goes into our mobile phones, it goes into electric vehicles, and more it's going to play a big role in sustainability. So I'm very excited that there'll be a series of very interesting talks and sessions that's lined up that will introduce some of the very interesting technologies and innovations from some of our members. So the Battery Consortium currently has about 32 industry members and about 60 individual researchers or scientists from the Institutes of Higher Learning. It is a platform that is very vibrant, that brings together many different aspects of expertise, experiences from industries, innovations from the IHL, and together this very tight-knit group of people aims to really push the frontiers in expanding and in improving battery technologies. I thank you once again for your time and your attention here, and I hope you will enjoy the program that's being lined up. Thank you.
Hello to everybody. I'm presenting a new material, lithium, aluminum, zinc, titanium oxide, supplied for anode materials to batteries and supercapacitors. 2D2 3D is a company founded in 2015 devoted to developing a new material, as well as production and trading of raw materials to different kinds of industries. Our lab is located in Turin, Italy, at the Innovation Center of the University of Turin, in the midst of one of the largest automotive hubs. What is the problem statement? Lithium titanium oxide cells can have long life and both high charge and discharge rates. However, they need improvement in reversibility. It means high discharge capacity after many cycles and increase in energy density. What is our technology offer? LAZTO has higher performance in the standard LTO, with high charge and discharge rates and with a very high Coulombic efficiency. This material can be supplied in few grams and 2 tons to prepare electrodes. What is the mode of collaboration we are looking for? First, R&D collaboration to develop targeted materials with a close relation with cells makers. And secondly, we are looking for business partnership and co-investment to develop cells in different formats, with location in Singapore and on Turin, Italy. Thank you very much for listening to me, and goodbye.
Good afternoon. I'm Feng Guoan from Singapore Energy Labs. I will introduce our solution about power battery pack enclosure integrate with liquid-cooled or air-cooled facility. Present battery pack normally adopts a structure of cell to module plus bottom liquid cooling plate. They are complex and costly, less effective and inefficient. It is also difficult to ensure that each cell can contact with the cooling plate evenly. Energy Lab has developed a novel grid structure, which MPT coolant loops are integrated into enclosure. This grid structure makes it lightweight, compact, and solid. With a simple and innovative flow connection, it ensures each battery cell's large surface is cooled or heated quickly, uniformly, and effectively. Additionally, ensure grid temperature uniformity. By eliminating module and simplifying the structure, the weight and the cost can be reduced, and it is also convenient for assembly and replacement of a single cell rather than the whole module during maintenance. These MPT are not only serve as a cooling duct plate, they also support cells and constitute a grid structure for the pack. The MPT bear no cell weights and vertical vibration load, and no stress from cell expansion because the stress offset on the two sides. In case thermal runaway happening for one cell, the cooling MPT will also block and insulate heat transfer, slow down or prevent the thermal runaway from spreading, improve the safety of the battery pack. Because the contact area is large, the heat conduction distance is short, so the heat transfer efficiency is 50 to 80% higher than the cooling of the bottom or the side edge of the cell or module. Two cells as a group are installed in a cooling grid. The foam between the two cells is used for absorbing the expansion of the cell and assisting the fixing of the cell to keep the cell pressed uniformly. The whole enclosure is made of aluminum alloy and braced together simultaneously by continuous atmosphere bracing process. So this enclosure can be manufactured with consistent quality at low cost for mass production. Even just cooled by circulating tap water from above test, the maximum temperature of the cell is 48 degrees. The cooling effect is very good. The cooling water outlet temperature only increased by 1 degree. We can see that the efficiency is very high. Our solution brings a lot of benefits to our customer and end user. This design is flexible for both liquid cool and air cool solution. Both two options are IP67 waterproof for sale, which prevent moisture to corrode cell tape, where in most air cool solution faced. This is a case study of the use of cell to pack. Data from CATL show that the volume utilization rate of C2P has increased by 15 to 20%. The number of components has been reduced by 40%, and production efficiency has increased by 50%. The energy density has increased by 10%, reach more than 200 watt-hour per kg, greatly reduce the manufacturing cost of the pack. Our technology is proven by patent granted by all major EV and battery market countries. In conclusion, we make battery pack safer, performance well, fast charging possible, and lower its cost. If you have any question, please feel free to contact us. Thank you for your attention.
I'm Kanapan Chettiar, inventor and founder of Switching Battery. I'm here to give a quick introduction. Battery connection methods have remained unchanged since the 19th century. These are based on mechanical battery connection methods, whereas switching battery is wholly electronic. Most people are familiar with parallel and series, but not the patented para-series. Switching batteries' para-series electronic battery connection concept is based on the idea that activity is preferred to inactivity. Switching battery is more efficient than standard batteries as the increased activity of switching between parallel and series converts electrons from non-moving to moving state. You therefore get more kinetic energy from doing this. Switching battery enables cell balancing without separate battery management systems by extricating every electron. In renewable energy systems, the switching battery can instantaneously charge and discharge using software technology. Switching battery is based on exacting the voltage that is required by the load. It overcomes voltage drops and instabilities in standard battery systems. The speed of 50 to 60 Hz further matches the AC grid systems of most countries. This frequency is safer as it is lower than DC-DC converters. Switching battery is based on complete software algorithm that is intended to be highly efficient, as the hardware battery is combined with fast power switching technology. It is therefore both a battery with a switch and a switch with a battery. Let me explain. The battery with the switch mode enables exactness as the switching battery uses the patented para-series electronic battery connection method. When using two batteries of 3.7 volt in parallel connection, you will get 3.7 volt. When using the same two batteries of 3.7 volt in series connection, however, you get 7.4 volt. In the para-series mode, you may now obtain the load output based on the minimum of batteries which are in parallel. This is 3.7 volt, and the battery drains much slower. The maximum, however, is based on the batteries in series, and for two batteries, this is 7.4 volt. When more batteries are used in series, the current drains much faster because of the load requirement. You may adjust the duty cycle using software by merely adjusting the time when they are in parallel versus when they are in series. At a 50-50 duty cycle, you can obtain 5.6 volt. When the duty cycle is 80% in series and only 20% in parallel, the voltage becomes 6.7 volt. Similarly, when the duty cycle is 20% in series and 80% in parallel, the voltage is 4.4 volt. In renewable systems where solar PV is used, the current generated is DC or direct current. We presently use electromechanical devices such as inverters for this. Switching battery is a high-powered switch with storage that enables easy conversion between AC and DC systems. Firstly, it smoothens fluctuations in solar PV by using storage capacity within the batteries. Secondly, it enables constant DC output to the load when required. Thirdly, it enables sinusoidal waveform for AC applications. All this is done using switching technology alone. It dispenses with electromechanical systems which generates heat loss due to unstable current flow. The switching battery is a more holistic system as it combines the flexibility of software technology with a hardware battery. It is the battery of the future. Switching battery is the 21st century battery system. Thank you.
Good day and welcome to our presentation of GenPlus Innovative Energy Storage Solutions for a Sustainable Future. I'm Lionel Mo, Head of Clean Energy Research at GenPlus Private Limited, a local technology-centric small and medium enterprise that aims to solve your energy storage solution needs with innovative solutions. Incorporated in 2013, GenPlus has grown as a boutique manufacturer for energy storage systems and has customized energy storage solutions to our partners all over South Asia Pacific. Each deployment is a unique project, and we have now provided solutions that cover rural electrification, renewable energy integration, grid services, and small portable power for ruggedized terrains, all with their innovative spin to provide solutions to power a sustainable future. As climate change brings more extreme weather and makes our planet unlivable, it is well accepted that renewable energy is one important solution to minimize our carbon footprint. Only when we have clean energy, electrification of our energy needs, such as transportation and heating, would become less carbon intensive and reduce greenhouse emissions. But renewable energy sources such as solar and wind are notorious in creating instability in our grids because of their intermittency. Electrification of our energy needs could further fuel instabilities as our grid gets more strained due to the higher load. In both cases, renewable energy and electrification, new innovative
energy storage solutions are needed to provide a stable electrical source for our future. At GenPlus, our team of experts aim to solve this problem by targeting 3 different areas in energy storage. Targeting mobility electrification, we have solutions that are customized for extreme applications such as ruggedized battery packs, marine vessel battery systems, and drone battery packs. For renewable energy integration, we have energy storage solutions with smart management to combat intermittency. And finally, answering to the core of sustainability, GenPlus is working today to develop tomorrow technologies and processes to combat imminent growth of retired batteries from EVs, giving these retired batteries a new lease of life. With repurposed retired batteries, GenPlus strives to provide battery storage solutions while combating e-waste and minimize carbon footprint. At our facilities, we have all the necessary capabilities and equipment to create most of the common builds of battery packs. This provides us with the flexibility to innovate and create new designs to suit your needs. Our battery testing facilities also cater for testing of battery cells at rapid charge and discharge speeds and allow us to test out our innovative designs in battery packs and battery management for niche areas such as battery packs for marine vessels. GenPlus also specializes in larger storage systems from design to system integration and operation. Our in-house battery and energy management system allows us to create customized solutions and optimize their impact on mitigating intermittency, peak shaving, providing grid ancillary services, and optimizing for power quality. And finally, as Singapore and the region begin to electrify transportation, we expect a rapidly growing amount of battery e-waste from electric vehicles in the near future. Focused on our mission to provide a sustainable future, we have started our own in-house development on innovative methods for battery evaluation and battery health estimation to evaluate batteries for repurposing. These methods would be used together with quality processes that meet international standards in repurposing batteries. Through our process, good modules are then equipped with our battery management systems and deployed in repurposed energy storage systems that are now currently test-bedded with our partners in Singapore. We are looking for partners or customers who are interested in developing battery packs and would like to deploy and test-bed battery and storage solutions in their facilities. Thank you for your time, and here is my contact information. We hope to hear from you soon.
Hello to all the participants of Tech Innovation 2021. My name is Stephen Gao. I'm the General Manager Commercial at Green Li-ion, and I'm about to present our technology on recycling spent lithium-ion batteries. Green Li-ion was established in Singapore in May 2020 with a mission to rid the world's landfill of discarded lithium-ion batteries and to consequently reduce the reliance on mining by the energy storage industry. This will be achieved with widespread distribution of our GLMC technology, which can fully rejuvenate lithium-ion battery cathodes from crushed and shredded used batteries. As an innovator in research and development of technologies in lithium-ion battery recycling, our strengths lie in the 3 PhD key hires that we have, 2 of which have over a decade of translating novel science to world first-class industrial size solutions. Governments and industry leaders agree that the ongoing disposal of spent batteries into landfill is not a responsible practice from an economic and an environmental perspective. The lifespan of lithium-ion batteries is 1 to 3 years. And the tremendous growth in the use of these has resulted in a great number of used batteries being discarded into landfill. Disposal of these into landfill causes serious environmental problems because the batteries are made of hazardous components such as heavy metals and electrolytes. Battery specialists and environmentalists all over the world give a long list of reasons why we should recycle lithium-ion batteries. The precious metals recovered can be used to make new batteries and lower the manufacturing costs. Currently, these precious metals account for more than half of the battery's cost. The purity of these exceed the purity in natural ores, making used batteries akin to highly enriched ore. If these precious metals can be recovered from used batteries on a large scale and more economically than from natural ore, the price of batteries and electric vehicles can drop. Today, these used batteries can be rejuvenated into battery-grade cathode materials using the correct technologies, such as those patented by Green Li-ion. Our technology offers a solution to reduce the dependency on mining finite and precious battery metals through recycling. The solution is a hardware module that recycles spent lithium-ion batteries into pure battery-grade cathode material that can be reused to manufacture new batteries. Interestingly, and the way it's been designed, the module adds to current recycling facilities to improve and enhance the recycling process and the profits of traditional battery recycling facilities. Basically, our technology is faster, greener, zero toxic discharge, zero landfill, and lower reliance on mining. Purer. Battery-grade cathode material is purer than what can be mined from natural ore, and 4 times more profitable, increasing the profitability of existing and future recycling facilities. The application. With respect to application, our hardware module is designed to bolt on to existing or new recycling facilities to improve and enhance the recycling process and therefore the profits of traditional battery recycling facilities. There is only one market in the industry for this hardware, however, the primary application being for the production and the sale of ready-to-use battery-grade cathode materials to battery manufacturers at a price which is currently up to 6 times cheaper than the same materials produced from smelted or mined precious metals. Essentially, the technology is there at a time when we need it. And I would be very interested to talk to you more about this. So please, we invite you to our booth for further discussions.
Hi everyone, my name is Hang Wei, CEO and co-founder of Liron Power. I'm excited to share more about our LTO or lithium titanium oxide battery technology today. First of all, a little bit about Liron. We are a Singapore-based deep tech company focusing on the research, design, development, and manufacturing of next-generation batteries. So what are some problems that we face in the world today? Firstly, climate change. We all know about it, global warming, rising sea level, and so on. So this created a demand for renewable energy in the last 10 years. And the next 10 years, we're talking about e-mobility, not only cars, but two-wheelers, three-wheelers, drones, robotics, and so on. So these are creating huge demand for energy storage in the form of batteries, and demand for batteries is expected to grow exponentially. There might even be a shortage of batteries available. Besides that, there are still some problems with battery technologies today, such as the limited cycle life, the slow charging and discharging, the low safety. We can see this in the news every few weeks, and also partly due to the low rate of the cells and high temperatures of battery cells if we cycle at high charge and discharge rate. At Liron, our goal is to address these issues by developing high-performance quality batteries which improve safety, increase cycle life, which is capable of faster charge and discharge, and performing at high rate and wide temperature range. How we do that is through the strong and innovative in-house research and development, as well as external R&D collaboration with top research institutes in Singapore and globally. And with enhanced quality control during the various processes, and also with the aim to embark on smart manufacturing down the road, with cost reduction and sustainability as our focus. So Liron's LTO technology involves proprietary additives in our cells, and through extensive research for high battery performance materials and with strict process control. Having continuous improvement and innovation at our lab enables us to have a strong know-how and potential IP. The pictures over here shows a glimpse of our lab, our prototype cells, and also our battery packs, as well as an award of recognition for our innovation by Frost & Sullivan. The test result in this slide on the left shows our prototype cells at high stability cycled at 6 ampere. Compared to other existing battery cells formula, we can see that as we use a high ampere, the other cells might lose its stability over a cycle number, but the LTO still maintains this stable performance. Our prototype cells also show a stable temperature compared to other existing cells, which increases in temperature when cycled at 6 amp, which is quite high. So on the right, from our result comparing with other available LTO cells, we can see that Liron's LTO cell is showing greater overall performance in terms of the energy density. Applications for our cells are focused on 3 categories: e-mobility, renewable energy, and consumer products. These are the 3 areas that we can see the great market potential, especially in the Southeast Asia region, with the growing trend from changing this internal combustion engine to electric mobility, and also renewable energy storage to replace diesel gensets, especially in these areas with of the government city grid. So we believe these are the areas and which is applicable to our battery cells. So where are we now? Our roadmap and milestone, we can see from the arrow, we are at the stage where we like to bring our prototype cells into a small production scale, or we call it the pilot line, before we move on further to a mass production plant. We are looking for strategic business partners as well as strategic investors. And of course, we are also open to explore various opportunities where we can grow together. So thank you so much, and I look forward to meeting you at our booth. You can also visit us at www.liron.live. Okay, thank you. Thank you for your time.
Battery energy storage system. Narada is a manufacturer of lead acid and lithium-ion battery. We specialize in high-temperature battery, lead carbon battery, specialized battery for data center, and even lithium batteries. Narada is established and publicly listed in 2010, and our yearly revenue is across 1.2 billion. Today, we have more than 7,000 employees worldwide, and Singapore is the regional HQ for APAC. My name is Peter Ng. I'm the business advisor for Narada Singapore and Narada Asia Pacific business. In today's energy transition challenges, energy storage plays an important role in solar plant output power quality consistency. It acts for mitigation against solar intermittency due to the sudden weather fluctuation and cloud movements. Energy storage plays to support the frequency regulation stability operation, where energy storage responds to absorb power when frequency goes higher than 50 Hz, and discharge power when frequency goes below the tolerance allowed. Energy storage is used to participate in energy plan. It supports for regulation, support spinning, reserve, and primary reserve, contingency reserve. Today, energy storage participates in smart grid integration of distributed energy resource operation, especially in demand and response application. Energy storage improves power quality delivery. In the 3 areas of long-term, mid-term, and short-term application, for grid transmission, energy storage in long term can act for peak shaving, power flow, and energy optimization. For mid-term, it can be used for secondary frequency and voltage regulation or black start. And for short-term, usually it applies for primary frequency voltage regulation. Now, in terms of power plant, it can be used for peak shaving and power curtailing applications. And also in midterm, it suppresses the renewable fluctuation energy. It supports the frequency regulation for AGC applications. Now, in short term, energy storage is used for power leveling in power plants. Especially it comes to the load, energy storage can help you save electricity fee. Example, in the tariff where there is difference in peak rate and off-peak rate. And it's especially useful for demand response application. In midterm, it can be used for suppressed fluctuation and sometimes even has a backup power. And short term, it will be used for peak shaving and load shifting. In energy storage, we divide into two focus. One is the energy capacity, and the other one is the power requirements. In cases where there's high energy capacity is a priority, we can use the lead carbon chemistry, where the backup time can be more than 4 hours. And in cases whereby energy capacity is of importance, then we can use the lithium battery. These are usually in cases where the backup time may be less than 2 hours, and we use the lithium LFP batteries for peak shaving, for time shifting. In situation whereby there is a balance between the energy capacity and power rating, so we will use the 1C design, like lithium battery. These are in the application for power smoothing, for ramp up rate control. And in situation whereby power has a higher priority than the energy capacity, we could use the lithium battery. In this situation, we will usually be less than an hour, and it will be used for the 2C application design. In certain situations of extreme high power requirements, usually the backup time is less than 15 minutes. In this situation, we may then have to use our design for 5C lithium battery. These are for frequency regulation, for voltage regulation, and especially in certain applications for high surge in IDC. Today's energy is divided into 3 portions for our fully integrated energy storage solution. The first part is the battery energy storage. The second area is the PCS, which is the power conversion system, which is also important for charging and discharging of battery. And finally is the energy management smart integrations. So our energy storage system has to be able to be IoT-based ready. Now LAR is looking for 2 groups of partners. One is the channel distribution partners to distribute our batteries and our solutions and to trade. And the other area is that we are looking at solution partners. We can help participate jointly in consortiums of innovation and projects. Thank you.
Hello everyone, we are Volt 14 Solutions, and we develop integrated silicon anode platforms for lithium-ion batteries. As a quick overview of our company, we are a venture-backed startup based here in Singapore. Our investors include leading early-stage investors, such as 500 Startups, Entrepreneur First, and the corporate venture arm of the Hong Kong Science and Technology Parks. Our anode platforms are targeted towards lithium-ion battery cell producers. These producers are for electric vehicle manufacturers, stationary energy storage systems, consumer electronics, defense, robotics, any application of a lithium-ion battery. The anodes that we offer, which is effectively a subcomponent inside battery cells, enable up to a 40% improvement in energy density at a price point that is competitive against the current state of art. We offer seamless integration into existing production lines and greatly reduce the R&D costs that is required from our adopters. Compared to other comparable products in the market today, we are offering 3 times higher performance, the lowest cost of adoption, and a process that is highly scalable for the huge production volumes that is required in the battery space. Currently, we are a seed-funded company with our technology patent protected. Our core team is established, and we are undergoing sampling with some of the leading players in multiple verticals. The International Energy Agency recently listed us among the 40 startups in the emerging market whose progress they will track over the coming decade. The main problem that we're trying to solve today is that batteries today are not good enough. They are very expensive. In electric vehicles, batteries make up to 30% of the cost of the entire vehicle, making it the most expensive subcomponent inside a car. Inside stationary energy storage platforms, they make up north of 80% of the cost of the entire modules. And these are modules, these are systems that will increasingly proliferate our lives, our homes, and our grids. Batteries do not store enough energy for this size. This means if you are driving an electric bus, if you're driving a forklift, you need multiple charge breaks throughout each shift, reducing your operational efficiencies. In consumer electronics, batteries take up a lion's share of the PCB real estate inside a device, greatly imposing design constraints in your system. Volt 14 solution is addressing all these problems by developing a high-performance anode that improves energy densities, reduces costs, with little to no change required in existing battery production infrastructure. This means longer EV ranges, greatly reduced battery costs, and higher performing and longer lasting consumer electronic devices. And we do this by creating an alternative anode system, a silicon-rich proprietary Volt 14 anode system to replace the graphite-based anodes in batteries today. The use of silicon to improve battery performance has been explored by multiple players, and there are existing and upcoming products. Most of these products are silicon-based powders produced by materials or chemical companies. These are silicon particles that are optimized for use in battery anode applications, which are procured by battery cell companies, who then go on to develop anodes that use these silicon materials in different amounts. There are two key problems with this. One, the adoption and the use of these silicon materials is not straightforward. It requires years, sometimes, of R&D efforts into formulation engineering, into electrode development, into material testing and qualification to use these anodes. Secondly, although these silicon anodes are based on a very promising theoretical concept, these silicon materials that are current and upcoming over the next several years can only be used in small amounts in anode formulations, meaning that the net gain enabled is quite minimal. Volt 14 solution is not supplying merely silicon powder or silicon material. We are supplying to our customers fully integrated anode solutions that contain not an additive amount of silicon, but up to 50% silicon, offering best-in-class performance. Also, a performance is tunable, which means that we can tailor an anode, we can tune our anode to a wide spectrum of requirements for customers of various applications. As a high-growth startup, we have imminent plans to get to a pilot scale and a clear roadmap to mass production. We are seeking partnerships from players across the battery value chain, as well as industry partners and the investment community. We are looking for material companies who wish to use their products to enter into the silicon market space. Our platform can provide a vehicle to them to integrate their materials and create a silicon anode. We are looking to work with battery cell companies and end users to enable a high-performance battery for them. And of course, we are looking for strategic investments, scale-up partners, as well as opportunities for POC or POV. We are Volt 14 Solutions, and we look forward to speaking to you.